Hi everyone, how are you all? First of all, I just want to say sorry for not posting or for not uploading any video from quite a long time. I was so busy with some of my personal stuff here and there. But now the devil is back, and now you can expect a back-to-back videos. Basically, every week you can expect one video at least. But in the scope of this video, we are going to discuss a very important question which is usually asked in interviews about memoization. First, we are going to see how we can implement it in vanilla JavaScript, followed by how we can do it in React. So without wasting any further time, let's go ahead and let's see how can we implement and how can we discuss memoization. So today we are going to discuss about the memoization. So let's discuss actually firstly, what do we mean by memoization, or what do we mean by this word memoize? So memoize is to remember something, right? So for example, let's say you go from position A to position B. For example, let's say from your home to your work. Now, you follow a certain path. You drive on the same path from A to B on your first day. Then you have to consciously remember that path. You have to do, some certain calculations, or maybe put your work location on Google Maps, or do some work, right? You do some work to reach from your home to your office. Second day, you mostly sort of like remember if it's at the local area, of course, but for the third day, third day, fourth day, fifth day, and subconsciously you remember the path automatically. You don't do any calculations, and you don't even do, put your location on Google Maps or something. You just remember it subconsciously. So here you don't have to do any calculations or stuff. And now, when you drive, even if your mind is somewhere else, you subconsciously reach to your work location, when back to your home, of course. So that's what we mean by memoization, and the same concept is applied in the program as well. For example, your program is doing some very expensive computation, and the very basic example of it is to find the factorial of a number, for example, right? So now what you want to do is, if you want to tell your program that, okay, if I computed the value of this number previously, I don't want to do that calculation once again. I don't want my program to rerun and to recompute and recalculate the value once again. So how is it going to happen? So what you're going to take a temporary data in somewhere in your program, which we can call as like cache or something. And once you have computed the value of that number, what you're going to do is, once that value is computed for the first time, you're going to save it somewhere. And what we are going to call that as our cache, right? So that the cache is nothing but just temporary data, temporary storage in your program. And what is it going to do is, definitely on the second time, for example, if you want to find the factorial of the same number, what it's going to do is, it's going to see, okay, do I have it saved somewhere in my cache? If I have it, I'm just going to fetch it from my cache. I'm not going to recalculate. This is so expensive, and I don't want to recalculate it, right? So you get the value from the cache and not recalculate the entire calculations once again. Why are we using this technique? As it is definitely implied, since the program is remembering some results, some computations, next time when you will try to do the same computation for the same number, it's not going to recalculate. And if it's not going to recalculate, it's going to be, your program is going to be more efficient, it's going to be more faster, and definitely more optimized. So memoization is a very good technique for optimizing your programs, for optimizing your applications. Of course, we are going to discuss how it's going to impact and how does it work in React as well. So when you're working with the large scale applications, how can you optimize your applications just by implementing this memoization technique? So a lot about the theory and stuff. Now let's go and let's check how can we implement this program that we have just discussed about the factorial function, right? So let's just write a factorial function first of all. It's like a simple function. It's going to take a number, and we are going to find the factorial of this number, which is very simple, n into, and then you will call the factorial. We are not going to discuss the logic of how the factorial is working, but it is just a simple recursion. For example, if you want to find the factorial for 5, then it's going to say, okay, 5 into, then again call the same function, but on 5 minus 1, that is 4. So 5 into 4, and then again you'll have 4 and then 4 into factorial of 4 minus 1, which is going to be 3. So 3, then 2, then 1. And there'll be two conditions. If the n is definitely less than 0, then the factorial is going to be this. And if the n is less than 2, then it's going to be 1. Otherwise, we are just going to return the factorial for this. And I'm just logging something here, factorial function, let's say. And now I'm going to call our factorial function for 5. And I'm going to call it 2 times actually. So when we are running it, compiling it, you can see the factorial function ran for number 5, then for number 4, then 3, then 2, then 1, and finally we got our value, which is 120. Now when we are calling it second time, the same thing is happening. Factorial function is calling for 5, then 4, then 3, then 2, then 1, and then finally it gave us 120, right? So this is a simple factorial function. It is not optimized. There is no memoization or anything of that sort is implemented in factorial function. But if I have to do it, then what we need to do? We just need a cache, first of all. And cache is nothing but your empty object. You can call a map, which is going to be a key value pair. So the key is going to be the number for which you are trying to find the factorial, and the value is going to be the actual value that you get as a result from this function. So now what we are doing is we are computing the value here. So first thing is we want to set the value, whatever value we have computed for that particular number, we want to set it in our cache. So it's very simple. Whatever value you found, like whatever number you are trying to find the value for, that is going to be the cache. That is going to be the key in this cache, and the value is going to be whatever you computed, which is n into factorial of n minus 1, right? And then finally you will return it from here. Now we have set it, and now the final part, which is the magic here, which is you need to check basically if the value exists in cache. If it exists in cache, you don't need to do this computation. That is the entire crux of using memoization. So you can simply say, if I can find my number in cache, if I have already something in the cache with this number, then just return its value. I don't want to find anything. I don't want to do any computation, and I don't want my function to rerun the entire calculation once again. So like that. And now when we run it, let's just see what happens. Okay, so we have a factorial function 5. For 5, it ran, then for 4, then for 3, then for 2, then for 1, and you got the value. But now it again, for the second time, for the line 18, when we are rerunning our factorial function, what exactly is happening is going to see, okay, if there is something in my cache and it found the value of 5 in the cache, so it did not rerun the entire function and did the calculation, and it just returned you the value from your cache itself. Let's also check one more thing. What do we have in the cache? When we run it, we see because we are running, we are calling factorial function for 5 for the first time. There was nothing in the cache. For the 4, there was nothing in the cache. For 3, there was nothing in the cache. 2, nothing. 1, nothing, and finally you got the value. But when you call it, when you rerun the same on line 21, what you got these all values. So for 2, you have the value 2. For 3, you have the factorial, which is 6. For 4, you have the factorial, which is 24. And for 5, you have the factorial, which is 120. So next time when it came, it is checking if I have something like if 5 in cache. And yes, there is 5 in cache right here. So it is going to just return the value for that number, which is 120. So for the second time, the value that you got, it was the memoized value for 5, and there was no recomputation for finding the factorial for number 5. Now let's check if for number 7, let's say, because for number 7 it's going to run like 7 into 6 into 5 into like that, right? So let's check it and see what happens. And when you run it, So for 5, 4, 3, 2, 1, exactly, because we were running it for first time. But then when we were at the finding the factorial for number 7, it ran, the factorial function ran, it calculated, computed. Then for number 6 as well, it recomputed. But for number 5, when it came to number 5, it found there is something that I have in the cache actually, and I don't have to do the 5 into 4 into 3 into 2 into 1 once again for finding the factorial of number 7, because I already have it. And finally it got the value from the cache, and then it did 7 into 6 into 120, and the final value we have here. So does that make sense how memoization is working actually? And how it can be used to optimize your programs, to optimize your algorithm, and in your web applications as well. So now let's talk about the real magic here, which is how can you memoize a value in a React component, which is in your real web application, and how, first of all, we are actually going to see how it negatively impacts. If you have not optimized your component, and if you have not optimized your web application in a certain way, it can negatively impact all the elements on the browser, right? So we are going to see that, and then we are going to use the memoization technique in our React component. So let's do that. So here we just have a very simple boilerplate code that I have written. We have two counters, and this is the function which is updating the state of this counter 1, which is set counter 1, and then counter 2 updating the state here, and then we have two number. We are calling these functions over on the click of these buttons, and finally we are showing what's the value of 1 and what's the value of 2. It's a very simple code, and let's now just see how it looks at the browser. So we have 1, and currently its value is initialized to 0, and then 2 and its value is initialized to 0. So this is very simple. I'm doing it and it's updating the value. I'm clicking it and it's updating the value. So now let's see where the real fun begins. I'm going to write a function here which does something on your counter 1. Which is a simple function right here. Maybe it doesn't even do anything. It just simply returns your counter 1. It doesn't even do anything. But before returning, it is doing some expensive calculations. And we can just run a loop many times. Let's say this much is okay. Should be okay, but we'll see. And it increments the I. Right? So this is very expensive. And I saved it, and I'm just calling it here. It does something, and I'm just calling this function right here. Sorry, my bad. Okay, now let's see how it's affecting our application. So we have 1, and then we have 0, and then we have 2. So this 0 is counter 1, which the function we have called, and it's returning counter 1. Now let's click over here, and you can see a lag, a clear lag basically. If I increase it a little bit more, then the lag would be clearly visible. Yeah. Now you clicked. You have to wait for a certain period of time before it gets updated. Now this is counter 1. We can say, okay, it's okay that the counter 1 was a dependency on this, this function. This function was doing something with counter 1, and that's why it happened. Now let's see on the second element that we have on our browser, which is this function. This button has nothing to do, absolutely nothing to do with counter 1. But if I click over here, we can see the performance of all the events that are impacting this element as well, this button as well. This button has absolutely no dependency, has nothing to do with counter 1 or whatsoever with that function. But just doing that expensive calculation has impacted the performance of this button as well. The events that are happening, the actions that we are taking on this button are also drastically impacted. So that's where memoization comes into action when we talk about the React components. So what I want to do is I want to memoize where do I want to call this function that does something on counter 1. So it is implied that this function needs to be called only when counter 1 is changed. When the state of counter 1 is changed, only then you need to call this function, and not every time. So what exactly was happening is when you click on this function counter 1, its state changed, and then it went to the second line on your template, and it says, okay, just call that for me, and then you return me the counter 1. That happened. But now when you changed the state of on the third line, when you changed the state of counter 2, what exactly happened is the React component re-rendered, right? So once it is re-rendered, because the state of this component, one of the state of this component changed. So counter 2, its state is changed. So this entire template is re-rendered. So once it's re-rendered, the button is re-rendered and this function automatically called. Now this function automatically called, it does the computation here and then it returned the counter 1. So even when you clicked the counter 2, it changed the state of this component, which in turn re-rendered the entire template once again. And in the nutshell, it called this function. So what we can do is we can use our very famous hook, which is usememo. So this is the hook that we are going to use in React to memoize certain things, memoize a certain value. So we have this function, and usememo, we can call it here. It's very simple to use. It's a function basically that takes first parameter as the function or the thing that you want to do. And the second one, the most important one, is the dependency array. So I'm just telling React component that you need to call this function only when a certain state has been changed, not the entire states. A certain state, a certain something has changed, only then you need to call this function. And for me, this function just has a scope and just has the dependency for counter 1. So what I'm going to do is I'm just going to write like, okay, counter 1. My dependency, which is counter 1, when its state is changed, only then you need to call the function, not on the state change of counter 2. That's what a memoization is doing here. It's very simple to use in React, but let's just see how it severely impacts. And let's just also log something to see if it is actually calling or no. Okay, so we are back here. I click over here. It's still impacting because it's still calling, and it's impacting. It's lagging. On second, it's again should be lagging, and that's expected. But now when I click over here, you can see this button is now completely independent of the entire computations that we are doing in that function. It is completely independent. We are not even calling that function, and we can see how it impacts our performance. Yeah, but when you click over here, it's still going to show you the lag. It's still going to call the function. It's still going to do the entire computations. But using the usememo will do these computations only when it is absolutely necessary to do that, and not like anytime component re-renders on any state change. So that's how you can leverage the memoization technique in the React component as well. Okay, so that's it for this video, and I have some work for you to do after watching this video, because it doesn't make sense to watch the video and not do the practical work. So you have to go to the React documentation for this React hook usememo and read what has been written there, because it's coming from the first source of truth, directly from the React team, and it is a very good practice to always go to the first source of truth for anything that you have implemented and what it means to come from the direct team who are implementing this. That's always me. I always recommend and highly encourage you to go and read the documentation that's coming from the first source of truth. And second part, which is more important, is you have to go through and research how you are going to implement memoization in Angular, in Vue. Even if you do like 2 out of these frameworks, we are good, but you have to go research and have to let me know in the comment section below if you found the right way to implement it in Angular, Vue, or anytime you can write it in the comments or DM me directly on LinkedIn if you are guys facing any issues regarding any of the things where you are stuck in the videos, where you could not understand some part, or you need some more explanations or something. And that's it. That's it for this video. Thank you so much for watching it, and I'll see you soon in the next video. Hi guys, thank you so much for watching this video once again, and I just wanted to let you know quickly that I'll be conducting an open session either on 26 or 27 So if any one of you is interested to join, please DM me on LinkedIn and I'll send you the Zoom link right there itself. Once again, thank you for subscribing to my channel, and please leave a like if you like the content. Thank you, and I'll see you soon in the next one. Bye.